Hello and welcome to this lesson. In this lesson, we are going to talk about turning effect of a force. Before we look deeply into the topic, let's review a few things about force. In other words, what do we know about force? So in the introduction, I'd like you to pause this video just for a moment and answer the following question. The first one is, what is a force? The second one is, force is a vector quantity. What is a vector quantity? What is the SI unit of force? And finally, state at least 3 effects of a force. So go right ahead, pause the video slightly, pause the video for a moment and answer those questions. Okay, welcome back. Let's look at the solution to this question. The first one was, what is a force? A force is either a push or a pull. And you have seen this one before. You've studied this topic before. The second one is, what is a vector quantity? A vector quantity is a quantity which has both magnitude and direction. And of course, the SI unit of force is Newton. When it comes to effects of a force, there are very many effects of a force. Maybe you may have stated some of the ones that I have here. I thought about a force can change the way an object moves. It can speed up a moving object, slow it down, or even change the direction in which it is moving. Another effect is that a force can change the shape or size of an object. Like for example, over here I have a spring, a spiral spring with me. You can see the moment I apply a pull, the size of the object seems to change. That is one of the effects of a force. A force can exert pressure, and you've studied this topic somewhere in Form 1. A force can change an object. A force can make an object to turn about a point. And this is the content of this topic, turning effect of a force. So, in turning effect of a force, I want us to look at one definition, and this is the definition of the term moment of a force about a point. Moment of a force about a point is defined as the product of the force and the perpendicular distance from the point to the line of action of the force. Now that definition sounds terribly complicated. I'm going to break it down into various small chunks and you will understand that definition. But the first thing I want us to look at is, we always take moment about a point. This is the language that we are going to use. When we speak about moment of a force about a point, I want you to always talk about taking moment about a point, or think about moment of a force about a point, or the turning effect of a force about a point. Because if a body were to turn, they always turn about a given point. So that one is very important. So in this diagram here, I have this point O, and I have the force F, and I want to find the turning effect of this force about this point. So definitely I'm going to multiply the distance and the force. That's why we have the word product. Product means multiplication. We are multiplying two physical quantities. The first one is the force and the second one is the distance. Now, how is the force and the distance related to each other? I'd like you to observe that this dotted line here is the line of action of the force. In other words, the direction of the force. This is the point about which we are taking moments. The distance that is important here is the distance that makes 90 degrees with the line of action of the force. And that distance is measured from the point about which we are taking moments. So this distance here makes 90 degrees with the line of action of the force, and it is the one we are going to multiply with the force to get the moment of this force about point O. That one is very, very important. So O is the point about which we are taking moments, and we are multiplying the force and the distance in order to find that effect. So moment of F about O is equals to F times D. And remember, the F and the D must make 90 degrees with each other. In other words, the distance as measured from the turning point makes 90 degrees with the line of action of F. Now, since we are multiplying force times distance, the SI unit of moment is Newton meter. Here I should have said this is the SI unit of moment, not the SI unit of force. So let's change that. So the SI unit of moment is Newton meter, Nm. Be careful about this unit. Many times students make mistake and they start talking about Newton per meter. Newton per meter is the SI unit of a totally different physical quantity. So here we are talking about multiplying the force and the distance, and since we are doing that, we get Newton meter. Now when an object turns, it can turn either clockwise or anti-clockwise. So moment has direction, and for that case, moment is a vector because it has direction. It is either clockwise or anti-clockwise. So let's pause this video at this point. I was just introducing the topic as well as defining moment of a force about a point. So make sure that by the next lesson you have understood or you remember the definition of moment of a force about a point as the product of the force and the perpendicular distance from the point to the line of action of the force. And I'll see you in the next lesson where we are going to look at now how do we calculate moment of a force about a point. So we are going to look at several situations where we are going to calculate moment of a force about a point.